Hello, everyone, and welcome to our biology class. It is a pleasure to have you all here with me today. Today, we are going to be continuing to look at the Great Plague, specifically the Great Plague of London, which was responsible for killing approximately 70,000 people in 1 year. And today, we are going to be looking a little bit more about the infectious agent that was responsible for the plague and the various techniques that we can use to identify these type of organisms in the laboratory today. First, I would like to go over a little academic terminology with you guys. Some of this stuff should be a review, such as bacteria. These are single cellular microorganisms. They have walls, but they lack organelles. We've gone over the structure of different prokaryotic and eukaryotic cells. We know that our prokaryotic cells lack different organelles, such as the mitochondria, the nucleus, Golgi body, and other organelles that are in your eukaryotic cells. The cell membrane is a semipermeable rubber membrane surrounding the cytoplasm of a cell. We see this in your bacteria and your eukaryotes. Cell wall, a rigid layer of polysaccharides lying outside the plasma membrane of cells of plants, fungi, and bacteria. The bubonic plague, the plague was caused by a bacterium known as Yersinia pestis and characterized especially by the formation of buboes, which are basically swollen lymph nodes in your host organism. Yersinia pestis is what we refer to as a gram-negative non-motile bacteria, and we will be looking a little bit more at what it means to be gram-negative or gram-positive. There's one major difference in classification of bacteria is gram-negative and gram-positive. Gram-negative bacteria are resistant to multiple drugs and are increasingly resistant to most available antibiotics. This is due to an outer membrane that your gram-negative bacteria have that your gram-positive bacteria do not have. What gram-positive bacteria do have is they have a very thick outer layer cell wall, and this is made of a compound called peptidoglycan, and that layer is much thicker in your gram-positive bacteria compared to your gram-negative. Lipopolysaccharides, they are sugars and lipids, compounds that are built on the outer layer membrane of your gram-negative bacteria. And that peptidoglycan substance, that's what makes up your cell walls that's really thick on your gram-positive bacteria. Here's a little diagram so we can kind of see it. We have on the left our gram-positive bacteria, and on the right our gram-negative bacteria. On the left, you can see this very thick layer of cell wall made up of that peptidoglycan, whereas on the right, the gram-negative cell is a very thin layer of peptidoglycan. We can also see on the right that your gram-negative bacteria has two different cell membranes, your cytoplasmic membrane around the cytoplasm and your outer membrane, which is on the outside of that cell wall. And you also have these lipopolysaccharides on the outside of your gram-negative cell membrane. Those lipopolysaccharides, they're also responsible for secreting different chemicals that cause cells to die, which is where you start getting symptoms and eventually death in your host organisms. The laboratory technique that we're going to be looking at today is called the gram stain. And what we will be doing as we carry out this gram stain, we're going to take our bacteria that we've been growing in the lab for the last 2 weeks, and we are going to place it on a slide. And then we are going to add a substance called crystal violet, which will dye our peptidoglycan. It will dye it purple. And again, we have that thick peptidoglycan on our gram-positive cells. And then we're going to add iodine, which is going to cause that peptidoglycan to really hold tight and adhere to that crystal violet dye. And after we do that, we're going to add alcohol, which will wash off our gram-negative bacteria. So it's going to lose all that purple dye. And then we're going to add a different dye called safranin, which is a kind of pink reddish, and it's going to really bond to those lipopolysaccharides of our gram-negative cells. So our gram-positives are going to appear purple because that peptidoglycan is really binding to that violet dye, whereas the gram-negative, the lipopolysaccharides, are really binding to that saffron. And what we will see as we put these under the microscope is something like this. We will have our purple bacteria, or it's going to that's going to be our gram positive. And what we're seeing there is that dye binding to that cell wall, that thick cell wall made up of peptidoglycan. And on the right, we have our gram negative with our lipopolysaccharides really sucking in that safranin dye that we added in our last step. So we'll be able to differentiate what type of bacteria that we've been growing over the last couple of weeks. And we'll be able to see some of the structural differences of that bacteria have. This is a technique that people all over the world are using in the lab to identify harmful bacteria that can cause much sickness and potentially death to their patients. So this is a very important technique that is still used, and I'm really looking forward for you guys coming to class tomorrow so we can perform this together. Please make sure to look in Google Classroom. I will post these slides so you can look at the academic language a little more prior to class. There's also an article for you guys to read and a worksheet that will help you guys understand some of these processes and really get a hold of some of that terminology that we've gone over. Um, I'm looking forward to having you guys tomorrow. Uh, Look over that stuff, and we will have a lot of fun together in class. I will see you tomorrow. Bye bye.